Chapter 1, Equations and Inequalities. Section 1.1, Applying the Properties of Real Numbers. The numbers that mathematicians deal with are real numbers and imaginary numbers. In the first part, or most of this trimester, we're going to be dealing with just the subset of real numbers. And real numbers, then, are broken up into two subsets. They can be rational numbers or irrational numbers. Rational numbers can be written as a fraction, and this in turn can be written as a terminating or repeating decimal. So for example, 3/8 would be a rational number, or 2 could be a rational number. 0.361 because that decimal ends, or 0.2 repeating is also a rational number. The easiest way to identify an irrational number is that if you change it into a decimal, it would be a non-terminating or non-repeating decimals. So the most popular or famous example of an irrational number would be pi. Or there's another number that we will deal with later in Algebra 2, and it's e. If you tried to change the square root of any non-perfect square number, you would get a non-terminating, non-repeating decimal. So the square root of 2, or the square root of 50. These are all irrational numbers. The next smallest subset of rational numbers would be integers, and these are positive and negative whole numbers. So all of your positives from negative 100 to negative 99, all the way to negative 2, negative 1, 0, 1, 2, 3. Any of those positive or negative whole numbers are called integers. And our smallest set of numbers, these are actually the first numbers that you ever encounter, are your counting numbers, including 0, so they're called the whole numbers. So 0, 1, 2, 3, and on and on and on. So when you first learn numbers, you learn that you have 0 candy bars, then you have 1 pencil, and so forth. So now when you're asked to graph numbers, you could put this in a calculator. However, if you're not allowed to use a calculator, let's look at where the square root of 5 would lie. Well, obviously it's going to be lying on the negative half of the number line. And if we think about this, the square root of 5 is somewhere between the negative square root of 9, and the negative square root of 4. Well, the negative square root of 9 would be negative 3, and the negative square root of 4 would be negative 2. And so this is where the negative square root of 5 would lie. And obviously 5 is closer to 4 than it is to 9, so it's going to lie closer to negative 2 than it is to negative 3. 7/2, if we change this into a mixed number, we get 3.5, and so 3.5 is halfway between 3 and 4. Then make sure when you label your numbers on a number line, if you did put this into a decimal, you still need to label the number line with the number that was given in the original problem. So this isn't actually 3.5, but when you label your number line, you would label it as 7/2. There are also 4 properties, common properties of numbers. However, you need to realize that these properties only hold for addition and multiplication. They don't hold for subtraction and division. The first one is the commutative property. The way I think about the commutative property is the distance from your school to your home is the same whether you go from school to home or home to school. In other words, it doesn't matter the distance or the direction that you travel, the distance is the same. So the same with numbers. If I add a plus b, that's the same as adding b plus a. And this holds for multiplication as well. So a times b is the same as b times a. The way I always remembered the associative property was if I have something to tell, let's say there's 3 friends, a plus b plus c. And if I'm a and I have something really cool to tell my friends, I could tell b first and then we could tell c. Or, let's say I'm b, I guess. Or I could tell c first and then we could tell a. In other words, it doesn't matter who I associate with first. I'll end up knowing that juicy bit of information in the end. The same with multiplication. I can multiply a times b and then that product times C, or I can multiply B times C together first and then multiply it by A. I'm going to reach the same product. The way I remember identity is if I get my hair cut and I wear pants and I wear a tank top, okay, I'm the same person as if I let my hair grow long and I wear a long sleeve shirt and shorts. In other words, I am who I am, and if I add 0 to it, I remain who I am. That would be the identity product for addition. So 0 is the identity. In other words, I can add 0 to anything and not change that thing, that number. The multiplicative identity would be 1, because I can multiply 1 by anything and I still get that same number. The additive inverse, in other words, what can I add to A so that I end up with the identity? And of course, I would add the opposite. So the additive inverse is another word for that would be the opposite. The same idea with multiplication. What could I multiply A by so that I get the multiplicative identity of 1? Well, hopefully you recall that you could multiply by the reciprocal. So another word for the multiplicative inverse would be reciprocal. So you should take a second and pause this right now and see if you can determine what these three properties, or what these three problems, which property they exhibit, and then put the video back on and see if you were right. Hopefully you have correctly identified the first one as the commutative property of addition, because it doesn't matter which order we add them. The second one is the associative property of multiplication, because it doesn't matter which order we multiply in first. And the third one is the additive identity, because we're adding 0 to 250 and we maintain that value of 250. You need to make sure that you think about subtraction as adding the opposite. So A minus B is actually A plus a negative B. In other words, if I were to ask you what two numbers you were adding together, you would tell me A and a negative B. So if I were to have an example, such as 3 minus 6, I could change this to adding the opposite. And so this is actually 3 plus a negative 6, which we know as negative 3. Changing the addition to adding the opposite really becomes most important when you have a double negative. So if I had 4 minus a negative 7, you really should get in the habit of changing these to a positive, adding the opposite, so minus a positive 7, and then it's a lot easier to comprehend that this is actually 11, because we're adding 4 plus 7. Again, sometimes it can be extremely useful to understand that division is actually multiplying by the reciprocal. So A times B can actually be rewritten, oh, I made a mistake, this is actually A divided by B, can be rewritten as A times 1 over B. Now, if you have two whole numbers, if A and B are two whole numbers, perhaps it's easier just to divide those. But if you have something like 6 divided by 1/4, remember that we can change this into multiplication. This is the same as 6, change the division to multiplication, and then the reciprocal of 1 over 4 is 4 over 1, or just 4. And then a problem that perhaps you didn't think you could do in your head, a whole number divided by a fraction, becomes multiplication of two whole numbers. So then you can easily see that that is 24. We use unit analysis to check that when we're given a problem with real-life rates and ratios, that we can check and make sure that our answer and our calculations make sense. So you need to remember that the word per means division. So if I have dollars per hour, I can rewrite this as my dollars per hour. And so then whatever numbers I have, I can write them as a fraction, and I can change my units to more friendly units perhaps. So this first example, you work 8 hours and earn $60. What is your earning rate? So the first thing I would ask you is, if somebody asks you what's your earning rate, what kind of answer do you give them? You usually tell them that you earn a certain number of dollars per hour. So we could write this, as I mentioned, per means division, so dollars per hour. And then when we put our numbers in here, we realize that we have $60 per 8 hours. And when we divide this out, we realize that we have $7.50 per 1 hour, which we more familiarly would write as $7.50 per hour. You buy 18 gallons of gasoline at $2.65 per gallon. What is your total cost? Well, again, we have this per, so $2.65 per 1 gallon. Well, remember, what I have on the numerator can cancel with what I have on the denominator. So if I multiply this by 18 gallons, and this isn't a rate, so it's simply over 1, then you can hopefully see that your unit of gallons will cancel, because gallons on the numerator will cancel with gallons on the denominator. And when we multiply two fractions, we multiply straight across. And so then when we do this, we see that we still have the label of dollars. And when we multiply 265 times 18, we get $47.70. There is no label on the bottom, it's just over 1. So our total cost is $47.70. You drive 90 kilometers per hour. What is your speed in meters per second? So basically we need to be changing our kilometers into meters and our hours into seconds. So let's start off with the information we're given. We can travel 90 kilometers per 1 hour. Well, now we need to change kilometers. So in order for kilometers to change into meters, we need to have kilometers on the top and kilometers on the bottom, so the units will cancel. And we know that 1 kilometer is the same as 1,000 meters. So this is our conversion factor. So once we've got our kilometers to cancel out, we're left with meters. Now we just need to deal with our hours. We need to change our hours into seconds. Well, again, since my hours start off in the denominator, I need hours on top. And the simplest conversion is hours into minutes. And we know that 1 hour is 60 minutes. But we don't want minutes, we want seconds. So again, since my minutes is on the bottom, my conversion factor is going to have to be minutes on the top and seconds on the bottom. And again, 1 minute is equal to 60 seconds. So now again, when we see our conversion factors, we have our hours on the bottom cancel with hours on the top, and minutes on the bottom cancel with minutes on the top, and we'll be left with seconds. In fact, we'll be left with minutes per second. So when we multiply across all these numbers across the top, we are going to get 90,000, and our label is meters. And when we multiply across all these numbers on the bottom, we are going to get 3,600 seconds. When we simplify this, we're going to get 25 meters over 1 second, which we could write as 25 meters per second. And we've done our conversion factor. And this last problem, you drive 60 kilometers per hour. What is your speed in miles per hour? So in this one, we're still staying with our rate of hours. We just need to convert kilometers into miles. So again, let's write down the information we know. 60 kilometers per 1 hour. Well, our hours can stay hours, but we need to change our kilometers into miles. And again, since we're starting off with kilometers on the top, in order for that unit to cancel, we need to put our conversion such that the kilometers will be on the bottom. And by looking this up, I will tell you that 1 mile is the same as 1.61 kilometers. So again, when we do our unit analysis, our kilometers on the top will cancel with our kilometers on the bottom, and we'll be left with miles per hour. And when we multiply across, we get 60 miles in 1.61 hours. And when we divide this down, put this in your handy dandy calculator, you're going to get 37.27 miles per hour. So again, a reminder that the idea of this flipped classroom is that you've gotten the notes now, and you don't have to spend any more time working on your homework. You just have to have your note packet filled in and be prepared to come to class tomorrow to work on your homework. So if there's anything that you didn't really understand or were confused about, please make sure you write that down so we can go over that in class. As you go through your homework, you'll come across some other questions, and I will be available to answer those. We'll see you tomorrow.